Hey there, and welcome back to another MTCNA tutorial. As promised, we'll be discussing NAT or Network Address Translation in RouterOS packet flow by first reviewing what NAT is, its place in the overall RouterOS packet flow, and the way it works to make network connectivity possible. You might have noticed that within the official MTCNA course outline, we don't have a subject dealing with NAT in relation to packet flow. Nevertheless, acquiring this knowledge now will make future related topics much easier and more understandable. In MikroTik's documentation, under the Firewall and QoS menu, you have a page specific to NAT. NAT, or Network Address Translation, is a technique used to allow devices on a private network to communicate with devices on the public internet using a single public IP address. It allows LAN hosts to use one set of IP addresses for internal communications and another set of IP addresses for external communications. When a LAN uses NAT, we call it a NATed network. An important thing to remember is that NAT matches only the first packet of each connection and uses connection tracking to remember the required action for subsequent packets. Since NAT works on IP hosts, it operates on layer 3 or the network layer. In RouterOS, we have two types of NAT. First, there is source NAT that is performed on packets originating from a NATed network. In this situation, the private source address of a packet is replaced with a new public address. For reply packets coming from the opposite direction, a reverse operation is applied. In the routing flow, source NAT can be found in the post-routing stage. Next, there is destination NAT that is performed on incoming packets toward the NATed network and helps IP hosts on a private network become available to the public internet by replacing the destination IP address of a packet on its way toward a private network. Destination NAT is the final step of the pre-routing stage. Also, with the launch of RouterOS version 7, NAT has acquired two new input and output chains, which are traversed for packets from applications running on the local machine. The input chain is used to process packets entering the router and can be located in the input stage of the routing flow. The output chain processes packets originating from and leaving the router, and it's placed within the output stage of the routing flow. So let's imagine we want to ping the address of 8888 from the trainee PC, which means our packets have to travel through the lab and the public internet domain to reach their destination. By using the trace route from the Windows command prompt, we can actually see the router and the required number of hops for pinging 8888. As you can see, only the first three devices are inside our lab. But just so you know, the next two addresses you see here are also private IP addresses. To check this, you can copy an IP address, go to Hurricane Electric's BGP toolkit available at bgp.he.net and search that address there to see whether it is private or public. As we mentioned in a previous tutorial when setting up the lab, a ping packet moving from a private network toward a public network is just like a tourist with a local language going to another part of the world where people speak another local or a public language. Moreover, along the way, our traveler may come across other languages as well. In this case, the tourist must either be equipped with the knowledge of those languages or hire translators who can speak both their language and the languages of their destination. On IP networks, that's where NAT comes in. Now, let's study the behavior of packets in this example once they leave the PC. A packet with the source address of 192.168.199 and the destination address of 8888 is created, and it first checks its own network for that destination. Since 8888 is not available on the PC network, our packet refers to the default gateway on the computer, which here is 192.168.1.254, which can be found on the trainee router. Next, the packet checks the trainee router's routing table for a path toward 8888. And since the only destination address range here matching 8888 is 0000/0, the packet needs to refer to the corresponding gateway, which is 10.0.0.254 on the class AP. Oh, and rest assured, we will talk about routing in detail once we get to the routing module. To reach that gateway, the packet must now go to the class AP. However, since it still carries a private source address, it utilizes the help of the source NAT rule we created when we were setting up our lab. This rule separates the packet's source address and replaces it with a new one, which here is 10.0.0.1. Thus, the packet is now able to reach the class AP with this new source address. At this stage, the packet checks the class AP's routing table and again needs to go toward the gateway that matches 0000/0, which is 192.168.77.1. To do so, the source NAT rule on the class AP has to detach the second source address of our packet and assign another new address, which here is 192.168.77.237. And once the packet reaches our main internet switch, this process occurs again and again until the packet has made the number of required hops on the public internet domain to reach 8888. Remember that for all private addresses in our trace route, separate NATs will take place in order to pass the packet forward, and it is actually the very first public address on this route that will send the ping request to 8888. Now, the question here is what would happen to our ping packets if our lab networks were not NATed? The truth is, they will move across our lab and the internet domain and actually reach their destination, but reply packets on the way back would not make it. Why? Because without NAT, our ping packets would use a private source address, and some ISPs filter private IP ranges for management and security. Even if they didn't, the destination server carrying 8888 would not have any knowledge whatsoever of our private addresses. Therefore, a ping will actually fail because of reply packets being dropped in that destination server since they cannot find a route back to the source. However, using our source NAT rules in place, if we disregard all other public and private IP addresses that we saw in the trace route for the sake of brevity, reply packets will come back with the source address of 8888 and the destination of 192.168.77.1. And upon reaching each of the devices within our MTCNA lab, they will get a new NATed destination address until they reach their final destination, that is the trainee PC. Since ping packets are moving through the trainee router and the class AP, they will be regarded as forwarded traffic. And as discussed in previous sessions, this is the path forward traffic takes within the routing flow. This means that our ping packets will move through the pre-routing, forward, and post-routing stages. So with this knowledge, let's set up some firewall rules in stages 1.4, 1.5, 3.4, 5.1, and 5.2 to log traffic activity and see if what we said about packet behavior is actually true. First, we will disable all previous firewall filters as well as the source NAT on the trainee router. Next, we'll create our rules using 8888 as the destination address, ICMP as the packet protocol, pass-through as the action, and the relevant number combination as the log prefix, creating all 5 firewall rules one by one. Once we have created all 5 rules, we will open the log window and from the command prompt on the trainee PC, ping 8888. As you can see, our ping fails and we receive timeout messages. However, the trainee router is recording traffic activity from 192, 168, 199 to 8888. Moreover, as you can see, only the very first packet hits all 5 rules, and rules 1.5 and 5.2, that is the destination and source NAT rules, are only applied to this first packet, just as we mentioned in the beginning. The 3 subsequent packets follow suit and hit rules 1.4, 3.4, and 5.1 on their way toward 8888. Also, the counters on our NAT rules show the first process packet, while the 2 mangle and the single filter rules have recorded all 4 forwarded ping packets. This means that all 4 ping packets have moved through the trainee router toward 8888. Now, to check the opposite route taken by the reply packets, we will first reset all counters to start from the beginning. Then, all we need to do is to duplicate our 5 firewall rules, but this time use 8888 as the source address of the rules, since the packets will be generated by 8888 toward the trainee PC as their destination. Once those rules are also in place, all we gotta do is to ping 8888 again via the command prompt. Evidently, while receiving timeouts on our ping, we are still getting the same previous log records of the packets moving toward 8888, but not seeing any activity coming back directed at the PC. Furthermore, you can see the counters of our previous 5 rules record a number of packets, while the counters for the second set of rules remain 0. This proves that without NAT, our ping packets move through the trainee router and similarly the class AP and reach their destination, but reply packets cannot find a route back and are therefore dropped. Stay tuned for next session, in which we'll teach you how to use NAT as a firewall measure. If you have any questions, let us know in the comments section, and like this video if you found it useful.